Well, good afternoon, good morning, or good evening, depending upon where you are in the world. Welcome to today's Container Journal webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a very interesting, hopefully, webinar panel discussion today, and lots of information to go over. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it again on demand. We will be sending out an email post-event that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time today, during today's presentation, you have a question for any of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's presentation and go through all of the audience questions that we can. And we are also giving away 3 $50 Amazon gift cards at the end of today's presentation. So stick around, we'll be doing a drawing at the end of today's webinar and draw those 3 names. So good luck to everybody who is on today's webinar. All right, with that, we will go ahead and kick off today's webinar, which is Container Security, Securing from Within, a panel discussion. Our panelists today, if I can get my slides to work here, our panelists today are Glenn Kosaka, who is Vice President of Product Management and Marketing at NewVector, Vikram Kapoor, who is Co-founder and CTO of Lacework, and Shiri Ifsan, who is Product Manager at WhiteSource. Welcome to all 3 of you. Thank you so much for joining me today for this webinar.
Thanks for having us.
Great. Well, I would like to start out by having each of you tell the audience a little bit about yourself and your background. And Glenn, why don't we go ahead and start with you?
Okay, thank you, and thanks for joining us today. I helped launch NewVector about 3 years ago. And prior to that, in various security and enterprise software roles, most notably founded a data loss prevention or DLP company, which was acquired by Trend Micro. The NewVector founders come from Trend Micro, VMware, Fortinet. And so we've really tried to combine, as you can imagine, some of the networking expertise that comes from Fortinet with some of the virtualization from VMware, and then more traditional security technology from Trend Micro.
Great, thank you, Glenn. Vikram, please tell us a little bit about yourself.
Hi, thanks for joining today. My name is Vikram Kapoor, and I'm co-founder and CTO here at Lacework. We started around 4 years back, focused on cloud security, which includes like workloads and accounts and containers. Before that, I worked for about 15 years in security and big data kind of technologies, including at Oracle and Chromium.
All right, wonderful. Thank you, Vikram. And Shiri, tell us a little bit about yourself.
So I'm Shiri, I'm a product manager at WhiteSource. Before joining WhiteSource, I had various positions in R&D, mostly solutions architecture in the cloud world and also in the security world. And today in WhiteSource, what we basically try to do is open source management. So not only security, but also licensing and distribution. And me personally, I focus on the container management part of the security.
Excellent, excellent. Well, again, thank you all 3 for taking the time and joining me today for this webinar. Today's webinar is, as it's part of a series with ebooks. This is the container security ebook, which is not easy for me to say apparently. So everybody who signed up for today's webinar will also receive a download link to access the ebook. So it's also going to be available on the Container Journal website. So a lot of the information in today's webinar comes directly from that ebook, along with the expertise of all 3 of our panelists. So let's go ahead and dive into the discussion here. Obviously, we're talking about container security since that is what the ebook is about. So I'd like to kind of start out by talking a little bit about some of the issues and what are the issues containing or when talking about container security and really kind of how have they evolved? I mean, why is security now such an issue with containers? So according to the ebook, these are the biggest container security issues that are out there right now. And so, obviously they kind of run the gamut, but I'd really like to kind of start off by talking about some of these big security issues and, kind of take the pulse, if you will, on, where we stand in the market. So, excuse me. Sherry, why don't we start with you? Looking at this list here, are there certain ones that kind of pop out at you as kind of being like the big bad security issues that are, maybe most prevalent out there, or are there ones that, maybe are kind of surprising you?
Yeah, definitely. So I think that what we see with most of our customers is that the biggest challenge is really to have container image authenticity. I mean, really knowing where your container images come from, which is a challenge for every organization probably, right? So the idea is to know exactly where the images came from, whether if it's open source components or something that you packed in within your organization or got from a third party. I think that the biggest challenge here is really to keep track of everything and also to follow all the changes, because with open source security vulnerabilities, usually there are public fixes and you just have to upgrade to the new version. But with images, of course, it's a lot easier, but still not everyone does it. And this I think, is one of the biggest challenges, also in terms of container image vulnerabilities. So I think these really are the two that pop out. And if we want to talk a little bit about how we treat them, so I think the most important thing is really to have either a private repository, private registry for your images, and also sign the images with a digital signature to make sure that there is no image tampering, that no one is changing the images or the containers after they're already in the registry.
Okay.
Yeah, I'd like to add to that. This is Glenn. I think the reason we're seeing security becoming so critical and important on some of the surveys you're doing is that we're now seeing these images and containers go into production for real business critical services. And I think what companies are realizing is, there's a whole workflow that they've got to secure in their entire pipeline. And typically what we saw last year was they did focus on the left side of the pipeline, which is the CI/CD and the image authenticity, scanning, and those types of issues. But now that they're moving into production, a lot of these things you're seeing here, attacks, cross-container attacks, escaping, DOS attacks, they're all kind of runtime attacks. And not all of them are going to exploit a vulnerability, whether it's known or unknown. There's a whole bunch of attacks that can occur during runtime that are either traditional application attacks or zero-day attacks or insider attacks. And in addition to that, not only do you have those ones to worry about, but you have the recently disclosed Kubernetes and Docker vulnerabilities. So the tools that you're actually using are vulnerable to attacks as well. So the big issue to me is, how do you protect during runtime, and how do you get visibility that any of these things are actually happening?
Yeah, so I'd actually like to add to that too, and kind of mirror what Glenn said. I think one of the things we are seeing is that more and more as people deploy containers, and you do a lot before it gets deployed, like vulnerability management, for example, or making sure the images are right. But at the end of the day, it's running in production and it has access to credentials either through let's say, IAM roles or through secrets that might be available to them, not just via images, but also through like environment variables or things like that. And if an attacker does get a footprint into one of those containers and comes inside your data center, then there is another big impact to, like, what can happen inside. So visibility in terms of, like, is super critical. And I think that's part of the reason why all of this became like a lot more interesting now compared to, say, like 5 years ago. I believe is also because the way DevOps is moving and the way they are moving so fast and automated is that a lot of the old school tools in terms of IPs and ports are simply basically, very hard to make work on a cloud environment where you have auto scalability turned on and IPs change all the time and ports change all the time and containers move from one VM to another VM, and being able to get visibility, being able to figure out what's really going on in the production data center, and being able to kind of make sure things are great before it gets into production. I think all three kind of adds to that container security at this point.
Okay. So Glenn, you brought up kind of an interesting point, which was these actual attacks on the containers. And so, I kind of bucket container security in two ways. One is the attacks that companies have to respond to, and then the other is just kind of human error or error in setting up the container. So what do you think at this point is the bigger threat here? Is it a bad actor, or is it just kind of I don't want to say, well, I'll just say human error for lack of a nicer term.
Yeah, I mean, I think either one of those are ways to get at your sensitive data. So, or do things that you don't want people to do. So one well-known one was the Tesla exploit of the open Kubernetes console. So that was just a misconfiguration, and somebody got in, installed crypto mining software on Tesla's EC2 servers. So they didn't really steal their data, they just used their resources without Tesla knowing. But most of the ransomware attacks that you've been reading about in the past couple of years have been because of either open database, kind of default admin passwords or misconfigurations. So those can be very damaging. But by the same token, you also have, like, the Equifax data breach was an exploit of an Apache Struts vulnerability. And that was, of course, very damaging. And in that case, you could have Apache Struts running in a container. So there's all of these application layer attacks that exploit either known vulnerabilities or they're vulnerabilities that have not been discovered yet.
Okay, great. So Vikram,
I think human errors are probably, if you look at all the kind of number of attacks, not just in the past, but also kind of see how it's evolving, this probably accounts for like a vast majority of them, and partly because it's a very complicated system. Like if you're running on AWS, there are like 150 services, and every service has like maybe 20 to 100 APIs in them, and there are a lot of policies to write in terms of, like, let's say bucket policies to IAM policies. And then you look at Kubernetes, which runs in cloud, and then you have another Kubernetes API and and a complicated infrastructure to manage there. So it's actually pretty easy for people to make, like, simple mistakes, and that kind of leads to an attacker being able to come in. Now, once the attacker comes in, and then how open the internal environment is, then kind of governs how bad the impact could be potentially to the customer. So fundamentally, I think, like a lot of the errors kind of start with simple things that if you kind of look at them and you figure, oh, I shouldn't be doing that, kind of goes a long way in helping security to the next level.
Okay, so Cherie, I was actually going to ask you, when we're talking about these Kubernetes vulnerabilities and the Docker vulnerabilities that have been seemingly, coming a little more fast and furious these days. We're hearing about the security issues with Kubernetes and with containers in general. So, do you think that they're that they are more geared, that they're, excuse me, sorry, that these security issues are more of that human error, or are we talking about it just being a much larger attack surface for folks to go after?
So actually in containers, I think we have less attack surface actually. But the idea is that really it's a combination of the two. I mean, you have a lot of these in terms of container attacks and Docker attacks, as this is becoming more and more, the market adopts it more and more. So this is actually a matter of both, because if you have the most secure cluster and you have everything that's completely isolated and you have a sandbox to test everything and you scan your images, probably even if there is a vulnerability, you'll detect it a lot faster and you'll handle it a lot faster, if at all it will come to your even production environments. So it's really a combination of both. We do see a lot more breaches and a lot more security vulnerabilities in Kubernetes and in Docker these days. And I think it's just a matter of, the market adoption is also the hackers adoption. They understood that there is something to work with here. And as we have more and more adoption of Kubernetes and of container-based stuff, we will see more and more attacks or trying to attacks as well.
Okay.
Yeah, I mean, vulnerabilities can get exploited, and those could be zero-day attacks, or if they're not discovered yet, those are just the hackers finding a way in. Now, once the vulnerability is found, disclosed, and characterized, then if a company does not patch those immediately or have a process to identify where they're running and upgrade those, then you could consider that human error at that point, right? That they continued to be vulnerable to something that was already known.
Okay. So as the market for containers has grown, obviously we're hearing a lot more about the impact of security or lack of security with a lot of containers. So, do you think that and this is for anybody who wants to answer, do you think that the market is kind of lagging when it comes to container security, and when we're talking about the number of containers that are in the field now?
I think it is, although the education level is rapidly increasing. So I say the left side of scanning and building proper hardening processes into your pipeline, those are getting very, very well understood. I mean, people have a much more sophisticated knowledge of how to do that and how to build that in. But I think on the runtime side, that's the Wild West. Not very many people know how to secure things or even what to look for during runtime. And so they're putting containers in production thinking that scanning is adequate, but they don't realize that there are system vulnerabilities, there's zero-day attacks and insider attacks. And they also don't realize that the way they protected their traditional data centers with tools like next generation firewalls and endpoint security, those types of capabilities should also exist in a runtime environment for containers. They're no different, right? So, from our perspective, the network is the most critical part of runtime security, because hackers will use the network to get into your container or to your host and to expand laterally, also known as east-west traffic, and then finally to either connect externally to a command and control server or to do some type of data stealing. So you need to have network, but you also need to be able to monitor your containers and your processes and your file systems during runtime.
Okay. Does anybody want to add on to that?
Yes, I think I'd like to add one.
Go ahead.
I'd like to add one more thing to that. So basically, I think I completely agree that doing something in runtime, in being able to kind of have visibility into processes, net connections that these processes are making, and applications and containers that are running, and the files that are being deployed. is kind of super critical for real security. But I'd like to add that at this point, given how orchestration is kind of evolving and how containers are getting used, it's really about the application that you kind of have to kind of start thinking about. So a container that runs on one VM versus another, and it's the same application, whether it's using the same IP or the same or different server port, it doesn't really matter. What really matters is what the application is. And it actually makes much easier when people look at applications versus network. And in some sense, like, I think that's what's kind of lagging in right now, where people are kind of trying to get to the point where they can understand their infrastructure, which might be running, say, 10,000 or 100,000 containers, and be able to kind of do some math on, what is going on and how do I protect myself and how many distinct things do I have, and get some idea about how to kind of go about protecting it in real time and being able to find things that are anomalous at that point at scale.
Yeah, and I like to add to that one thing that we see, and all of us actually see it, is to think within the Kubernetes infrastructure or the open source part of this. Because, we heard about the run C vulnerability about a month ago. Last week, another vulnerability was disclosed within Kubernetes. So we do see more and more security vulnerability in terms of the open source part. And I think with this, it's becoming a little harder to prioritize, because you actually use many open source components. Not all of them are within the infrastructure. Some of them are just general open source components. And for example, if you just take some standard application, it will have hundreds of or thousands of security vulnerabilities. And I think that the biggest challenge of companies today is actually to prioritize and understand which are the critical vulnerabilities that they actually need to handle. So I think this is also another challenge that we see.
That's that's a really good point, and that kind of leads me to my next question, which is, how can you get security teams involved in container deployments? I mean, where do we need to get the security teams as part of that process? Cherie?
So as I actually see it, it's an ongoing process. I mean, from what I see it, we see DevSecOps, people becoming more and more inherent in the teams. So what I actually see is that if we start and we shift left, but shift really left into the coding and the research part, and we have the security teams already there, and then the security processes actually follow us to the build stage, and we can fail builds if we see that there are open source securities or other security vulnerabilities. And then in the image registry stage, we also have these processes of security. So it's, as I see it, it's really a matter of having the right processes in place. And we spoke here about runtime security, so it's exactly the same thing. If you have the right automation in place and you have the right tools in place, after you actually set it up, you just have to maintain it, and then it becomes more and more easy.
Okay.
Yeah, I think if you asked people what does DevOps mean, or what is SecOps or DevSecOps, you'd get a different answer from every person. So, organizationally, I think this is a big dilemma for companies that, they want to shift security left toward dev and maybe DevOps. But at the same time, there is very specific expertise like network or threat mitigation security that you can't expect every developer to understand. So first of all, there's figuring out the organization and just making sure that for the entire pipeline from build to ship to run, that somebody on your team is part of that discussion, that the left hand is knowing what the right hand is doing. And then secondly, I think automation does play a big part of this, and it's really the only way to get truly scalable, massive scale container deployments. But then the devil is in the details, in terms of what points do you automate, and for example, how do you automate in the pipeline which container should be segmented from other containers, or which connection services. How do you do network segmentation in that automated workflow? And working with some of our more leading edge companies, they're asking the development and DevOps teams to specify, how these services should interact and behave during runtime, so that they can specify what the security policies should be and therefore automate them. But I'd say the majority of companies are pretty far away from being able to define that and even implement that level of automation.
So I think automation is actually the only way that security can catch up with DevOps at this point, in some sense, where like DevOps community has kind of moved to everything is automated, infrastructure as code, immutable images, users being not allowed to log in as much as possible. I think a lot of the security stuff has to be automated. It has to move away from writing rules manually, because fundamentally, at scale, like when you have lots of containers, trying to even write a rule which says this container should do this or not do that, or how they should be commingled, is actually at the very architecture level. You can segment them, and beyond that, you have to really think of like automatic ways to write rules, enforce them, like using maybe pod policies. But I think automation is the way you can go do that. But I think more importantly, one of the things which is missing right now in DevSecOps teams is really a common language between DevOps and security people, where they can kind of understand each other's concerns in terms of applications. Like, so as a developer, for example, I would care about my application, but as a security person, I care about my entire data center. So, but to do that today, I need to understand my applications and what they are doing. So I think to be able to do like a good job for a team, effective security in an organization, automation is a must. They really need to automate to the point where they can do a lot of rules and everything automatically, and then have a common vocabulary where they could kind of talk about infrastructure as code. Like, for example, config has to be delivered as a piece of source code, not as a piece of on a UI, for example, like writing like a rule. So I think that's where the direction has to go for this.
So are there certain things that need to be considered then when we're talking about containers in the DevOps process that in a non-container DevOps process might not be as important or even necessary? I mean, what changes with containers in the picture? Vikram, why don't we start with you?
Yeah, it's the speed and the agility. Like, so when you have containers, like you're really bundling a whole Linux image in your container. And if there are 50 containers, then you have like possibly 50 different images, and every one of them have their own source code that they bundle, like, Python versus Java. And then as you kind of think about the agility, like you could deploy a container today in seconds at scale on a Kubernetes infrastructure. And all of the stuff that was earlier used to get visibility and get security, like IPs and ports, are basically meaningless. So I think as people kind of use Kubernetes and they use containers and they use orchestration tools like Kubernetes to manage the infrastructure, the speed and the velocity at which they're able to do things is immensely greater than the old world, and that makes them having to figure out how to do it at that scale.
Okay.
Yeah, it depends on what you mean by done differently with container. Do you mean like the developer and when they build the container image? Obviously, there's scanning and vulnerability management for that. But the container is then, or the image is then going to be deployed by something like Kubernetes. And there's a ton of things that you can do differently now with containerized deployments in Kubernetes. There's pod policies, pod limits, pod security policies, where these things are deployed, how ingress controls are done. So there's just so many things that can be done in that pipeline. And really the question is, just making sure who is responsible on the team for each of those parts of the pipeline.
Exactly. So I think it's really a matter of when you have containers versus VMs and traditional applications, you have a bigger challenge in the isolation, because as we discussed, we saw the Tesla breach where they used the actual CPU of the machine where the container ran. It's a lot easier than in a virtual machine to actually jump between different containers and have cross containers attacks versus traditional code. So it's both a matter of scanning the images and making sure that they are from a trusted source, but also protecting during runtimes. Like, for example, have admission controller in Kubernetes to make sure that everything that is being deployed to your cluster is also from a trusted source, but also has various other security measures, like, for example, root users or Docker stock or security vulnerabilities. So all of that, really packing this into Kubernetes or other container orchestrations, I think is very different from deploying traditional applications in terms of the security aspects.
Okay. All right, great. Looks like we are already at half an hour past the hour. So I'm going to go ahead and move on to the next topic, which is some of the best practices. And we go over a lot of them in the ebook, and I've got 3 slides listing some of the best practices that we have. But you know, basically, I want to put it out to our panelists. This is the first set of 5, but you know, we can go through each of these, but it would take probably a couple hours. So I think what maybe we should do instead is just kind of talk about what you guys believe are some of the best practices in securing containers, and whether that be getting security teams involved earlier in the process, or doing something to you know, to better lock down the containers, or you know, whatever you think is going to be a best practice or best practices that organizations should consider when deploying containers. So let's see, why don't we go ahead and start with you, Vikram, and then we'll move on to Glenn, and then Sherry.
So I think I would kind of argue, if you look at from the left to right discussions that we're having so far, some of the best practices that companies should consider is really getting the security teams involved early enough so they can make sure the configuration and the architecture is right for a lot of the Kubernetes and the cloud and the container world. So containers don't run in isolation by themselves, right? They run in a data center. A lot of those data centers are clouds now, and they need an orchestrator to actually orchestrate the containers, and Kubernetes being the most popular one. So I think looking at and making sure the configuration and everything is actually what it should be is like one best practice. Then you kind of move on to vulnerability management and making sure that you're scanning your images, so there's no known thing that's kind of leaking into your production environment. But also, once you run it, it has to be cross-validated every day, because new vulnerabilities are discovered every day. And then you have to upgrade the ones that you find the next day. And then kind of goes beyond that to actual production environment, where there has to be something which gives you visibility, like without getting visibility on really what every container is doing in terms of connections, process launches, privilege changes. You're kind of blind to the fact that like an intruder will basically move around, and you wouldn't be able to find them. So visibility and intrusion detection system that goes with it. And then beyond that, like, you know, if your cloud itself could be vulnerable, and you need to kind of make sure that also is secure.
Yeah, I would agree with that. And the interesting thing is, you know, the 1, 2, 3, 5 bullet points here are all about kind of locking down your system, preparing, trying to reduce the attack surface before you go into production. So as Vikram said, you know, it's not just that. Now, what are the best practices for runtime? And I think that's what's, at this point, what's the least understood. You know, how do you apply runtime security in a containerized environment? So, you know, the first thing we can do is we can take traditional security concepts and kind of examine how they apply to containers. And those would be, as Vikram mentioned, you know, network visibility. Do you have the ability to effectively have a next generation firewall between all your container traffic and all that east-west traffic that you now have. Do you have endpoint security that monitors the applications and the hosts? In this case, the application is the container, and of course the host is still the host. So do you have the ability to see when a reverse shell or a DNS tunnel process starts out within the host or within the container itself, and then tries to break out through the network, whether it's an external connection? So what's your best practice for applying those types of security preventions for a runtime environment? So those are all things that I think people need to consider. And then we always come back to the automation concept, right? How can you automate all of these items you have here as much as possible so that you don't have the user error that, I forgot to run the vulnerability scan before these images were put into the registry, or I forgot to establish the proper RBACs when this new Kubernetes cluster got deployed. And then finally into production, do you have a way to automate your network rules, your process profiling, and all of your response rules that and monitoring and logging in the runtime environment?
Yeah, I completely agree. I think that other than the tools that we have, what we actually need, and we see it a lot in various organizations, is to actually shift the mindset, because security cannot exist only in a specific point in the pipeline. It has to be continuous, and it has to start from the very early stages of the development. So what I would say is have proper gates. For example, checks for security issues in your CI/CD, for example, Jenkins or any other CI/CD tool that you use, and fail the builds if you have any security issues. So exactly as you work with nightly builds or daily builds, and you build your software and you have automated tests, and you actually fail the build because there was a functionality issue. So this exact same thing should exist with security issues. We already mentioned trusted sources, so always have the images taken from a source that you trust, whether if you sign the images with a digital signature or use any private registry. And also we mentioned this as well, that Kubernetes or any other container orchestration has some defaults. And usually it's very important to go over and understand these defaults in matter of security and actually change them according to the security best practices. And the last thing I think is to manage the deployment to your container orchestration. So even if you scan your images and everything is right and everything is correct and you have no security vulnerabilities, until the time that you actually deploy them to production, you can find additional security vulnerabilities. Some open source vulnerabilities can be published. So it's super important to also block images or block containers that have security vulnerabilities from actually entering production. So I think these are the main tools that companies that want to enhance the container security can use.
Okay. All right, great. So as you guys were speaking, I kind of went through each of the slides here for the best practices. So we've got about, I think about 16 or 18 best practices that we list in here. So you were talking about one, and I
some runtime ones in there.
Yeah, there is. there are. There are a number of different ones that we use. You can see, mandatory access controls, full virtualization, kernel level safety checks, tons of best practices that are in the ebook. So I do encourage everybody who gets a link to download the ebook to take a look through it. And I also want to make sure that we leave, about 10 or 15 minutes or so for audience questions. And just a quick reminder to the audience, if you have a question for any of our panelists, please go ahead and use that questions tab, the GoToWebinar control panel, and submit your questions, and we'll get to as many as we can. So, you know, one of the things that that we've talked about a little bit is the, you know, the attack surface, and Shiri, you mentioned that you thought that the attack surface actually was kind of smaller with a container, but you know, it seems like with so many containers out there, I don't know, I'm having a hard time kind of, you know, reconciling the fact that it's actually a smaller attack surface. So maybe we can talk a little bit more about that, and maybe, you know, some ways that organizations can kind of reduce their attack surface to, you know, to the bare minimum, if you will. Shiri, do you want to go ahead and start with that?
Yeah, so attack surface is actually sort of the sum of the different points where someone who is unauthorized can actually enter, either to see your data or to extract data from your environment. And we usually say that attack surface is smaller when speaking about containers, because within the Docker file, you can actually choose what's your base image, what's your Linux distribution that you're actually using. And instead of using Ubuntu, for example, that comes with a lot of unnecessary things, you can use a smaller distribution like Alpine, for example. And this already reduces the attack surface a lot. So it's really important to, you know, to understand the differences between using a VM where you have a whole operating system with a lot of files that you might not need for actually running the specific commands that you run within the container. So from that aspect, the attack surface is actually smaller. It doesn't mean that it's more secure than virtual machines, of course, because as we mentioned, there are a lot of security best practices that you have to implement in order to actually make your container orchestration and your container platform actually secure. So it's really a matter of, you know, your point of view and where you look it from. So yeah, so I think maybe that answers the question, but definitely there is a lot of risk. There is a lot of security risk when handling containers, but the attack surface is actually smaller.
Okay, all right. So
I actually feel that, yeah, I actually feel that the attack surface, like, even though it is true that the containers themselves have, like, you know, less amount of code, and it's more it can be restricted. Like, for example, you don't need to have a telnet in your container because you don't need it. But fundamentally, containers don't run by themselves, right? They run in an ecosystem. And if you look at the ecosystem, starting all the way from cloud to Kubernetes to containers, like, everything you do on AWS is through an API. And somebody with credentials can actually undo anything you put in there. They can change bucket policies, they can, you know, open security group ports, and there is no perimeter to define. Like, you know, every S3 bucket is available to anybody in the world, and the only thing that protects it is really, you know, the policy that goes with it, right? So essentially, the attack surface on AWS is big because you can kind of go through it through a lot of APIs that are available, and any human error can be exploited there. Same with Kubernetes, where you have Kubernetes API, and that can be exploited, or there could be bugs in there, and orchestrations. Like, once you get into one container, since the kernel is shared, you can kind of go through kernel and get to another container and do more attacks. So to me, even though the container itself is locked down, the ecosystem itself opens up a lot of attack vectors, and people need to be cognizant of that, especially when they design it. For example, if you're thinking of no secrets in public image, I would actually argue, like, there should be no secrets at all. Like, you got to think about encryption and a KMS service or another service which actually encrypts your secrets and are only available to a container when it's actually running on a VM, which is isolated from themselves, from each other, in a sense that, which is the second point of isolate based on functionality, where you want to have a DMZ set of VMs, or a VMs with access to database, or VMs with certain instance roles which might be privileged. So you kind of have to separate them out at multiple levels to limit the impact to the system if an intruder gets in. So I think, to me, like, when I think about it, like, the attack surface is pretty big, and you have to think at multiple levels to make sure you have layered security at all of those layers.
Yeah, I would agree. The other thing to add to consider is that in a monolithic application environment, you had a big app and with a bunch of different functions within it, and you protected it through the front door with a WAF or a next generation firewall. When you now deploy containers, you're typically moving to more of a microservices environment where that monolithic app could be comprised of hundreds or thousands of microservices now talking to each other, each of which has its own pod and an addressable IP address. And so now there's more opportunity to try to probe and try to attack and look for vulnerabilities by attacking the specific microservices that are exposed.
In fact, another point I would like to add there to that same point is that if you think of Kubernetes and you're running, let's say, an overlay network on top of the AWS network, for an attacker to be able to get into one pod and then be able to kind of go to another pod, at the VPC flow log levels, you won't even see any symptom of it because basically the IP space is completely different. So I think it kind of opens up a lot of different layers which were not there before.
All right, great. So given the time, we're about 14 minutes to the top of the hour. I just want to go ahead and throw this slide up there and get any final thoughts that any of you might have on container security and maybe your any suggestions or sage words of advice that you can give to organizations that are either considering moving to containers or already have and are possibly dealing with any security issues. So Glenn, why don't we start with you?
Okay, I'd say if you're new to containers, but you are considering or already have containers in production, then first of all, make sure you scope out that entire pipeline, the left to right for the entire process, to look for all points and then to map your organization against those flows. Those, how can you build security in to every step of that flow? And then don't forget runtime security, because it's really your last line of defense against a zero-day exploit or an insider attack, and or an exploit of an unknown, unannounced vulnerability. And within runtime security, we like to say the source of truth is the network, because as I mentioned before, that's how they're going to get in, get out, and move laterally. So make sure you have the right tools to be able to monitor those connections, segment the appropriate network traffic between workloads, identify the anomalies or the connections, and if possible, even just like a next generation firewall, be able to block connections, do the traditional things that security architects do and network security people do, like packet capturing and quarantine and forensics and reporting.
All right, great. Thank you, Glenn. Vikram, how about you? Any final thoughts, advice?
Yeah, so I would actually put on my dev hat or a DevOps hat for a minute, and I really like containers. Like, they really isolate application dependencies well. Microservice architecture is so much better than a monolithic architecture. You're able to do small updates into a running production system without having to worry about unknown impact to other things that you didn't think about. So I think from that perspective, containers really help solve a big problem in data centers today. And if you add on top of that, orchestration tools like Kubernetes or Mesos or Swarm, they really get us auto scalability. They get us cost effectiveness, velocity, and same with cloud at that point, like AWS, Azure, or GCP, where you get being able to do things that would be very hard to do otherwise, right? So I think that is the direction where the world is moving. And security teams have to be able to, at this point, adopt to that architecture and then kind of think about it the way, the architecture itself, and it needs the retooling of the security tools, basically. So it goes from all the things we talked about today, from vulnerability management, still layered security, where you look at AWS, look at your resources, look at your containers in runtime or at compile time, and then that's how somebody can be secure. really secure by making sure they have like all these pieces in place, and then obviously automating it as much as they can.
All right, great, thank you. Sherry, any words of advice, final thoughts?
Yeah, so I completely agree with both of you. Look, I mean, applications have changed in the recent years. So along with the change of pace, we need to deliver application faster. We have the technological ability to actually do so and break the code from a monolithic application to a very small pieces, and pack them into containers. And it's really important to also take security when we think about our continuous integration and continuous deployment, and we think about automating the way we deliver our software. Just don't forget the security part. So basically, look at your entire architecture and see what are the proper gates to put security in. The best practices would be, the first gate would be the research stage. So when you choose which component to actually use, make sure that it's secure enough. Sometimes we see organizations actually prefer managed services because they take part of the security role on their ends, and then the next step would probably be the build stage or the CI/CD stage. Then later on within your container registry, so think about how you protect your images, and then of course the runtime part. But you have to not forget each one of the phases, and make sure that you have everything automated.
Okay, all right, great. Well, I want to move on to the question and answer period because we have gotten some great questions in. I want to try to get to as many as possible. So let's just dive right on in. How can we tie the relationship between the developers and the infrastructure team and security teams when we're talking about containers? Whoever wants to grab that one.
Yeah, I think we mentioned the need to map out the entire pipeline from build to ship to admission controls to locking down the deployment environment, access controls, and then runtime. And the way to tie those teams together is to make sure that there's clear responsibility for each of those stages in the pipeline, and to get everyone in the room to review what's being done, what can be automated, the gates that Sherry talked about, what kind of gates are needed. Oftentimes we see just one team or another team, just deploying containers into production and just doing what they know for security, but they don't have that full view of the pipeline.
All right, great.
And
go ahead, Sherry.
yeah, maybe to add to that. So sometimes we have just lack of awareness within the organizations, or sometimes we just don't have enough knowledge. So really take advice from experts. There are a lot of communities online. There are a lot of tools that can help you with it, whether if it's open source tools or paid tools. So use everything. There is a lot of knowledge out there.
All right. Great. Let's go ahead and move on to the next question. How is kernel level security checks implemented in CI/CD, i.e. to fail container builds or deploy to private registry? Vikram, you want to take this one? It seems like it's a little more DevOps focused.
Yeah, to me, actually, kernel level safety would really be more important than runtime. So at a CI/CD pipeline, you can actually check for known vulnerabilities. You can do file integrity monitoring and check for all the hashes to be good or bad, or lock it down and remove applications you don't need in production in that container, like telnet or FTP or anything which is could be exploited in theory. But when it comes to actually running it, and if an intruder does come into the container, let's say through Apache struts, and then does a kernel exploit, most likely you will have to have something running on that VM to be able to figure out that container did that. So visibility, and then being able to do intrusion detection, that really there was a move from this container, and let's say it went to a command and control DNS and then downloaded something. So that, I think, to me is a more of a runtime thing, not at a compile time thing.
Yeah, I think that's
Okay.
why we all paused, because the build is more identification of source code issues and vulnerabilities, and kernel level stuff is when you're preparing the environment, for example, evaluating your SE Linux, your app armor profiles, making sure those are in place, or running the CIS benchmarks for Docker and Kubernetes.
Okay. All right, great. I think we have time for one more question, so we'll go ahead and grab one here. So here's an interesting one. Configurations should be congruent with security policies. So what's the ideal way to align security and DevOps goals? I would say communication, but that's just me.
Yeah, I completely agree. I think that there is a lot of issues between DevOps teams and between developers, but it's really a matter of, both communication and also understanding that the goal is the same goal for all of the teams together. So it's really a matter of working together. And also, I think that with these type of things, having the right processes in place always helps us to sort of have that same baseline. And then after you agree upon what are the processes, and this is actually a decision that you have to make together and make sure that everyone knows the roles and responsibilities. So after you've actually agreed on what are the processes that we're going to take, what are the actions that each team is responsible of, it will be a lot easier to actually cooperate and avoid these issues between the teams.
I would add to that, like, if you think of DevOps and security, a lot of it is actually about education on both sides and communication. So clearly, like, developers think about applications, right? Like, I write an application, I deploy an application, I'm responsible for an application or two. But a lot of the time, security kind of thinks infrastructure, like network and port and VMs. So I think that lingo has to kind of become the same, like the vocabulary has to become same, and security people have to really understand what the applications are and what they do, and what is a normal behavior for them and what's not normal behavior for them. At the same time, like in enforcing something, like in the old world, you could write a firewall rule to kind of change something, and that would be effective. But nowadays, everything is infrastructure as code. So you really need to think about configuration and how configuration gets updated or change control. So even the enforcement and the protection part of the config has to be more education on the DevOps side to kind of understand implications of those things from a security perspective. So I think it's the both teams who have to really get to the same vocabulary and educate each other in terms of how to effectively not just monitor and be able to have visibility and into what's going on, and then be able to from there get to an action which probably might have to be implemented by DevOps team in terms of a new code for it.
We're moving in the right direction with the whole shift left education, and so developers and also it's it's really security issues, routing, application performance issues are being virtualized and moved up from the bare infrastructure. I think the service mesh, Istio, Linkerd2, that whole popularity and the potential of that is helping to define, developers to understand, okay, once these services get into production, there's going to be a virtualized mesh that is going to take care of some routing, but they have to be involved with the conversation between them and the team that's deploying a service mesh to understand how they want their application to behave, and that also includes security. How can they monitor the security of it? Is there encryption required? How is authentication and authorization going to be part of the infrastructure, or does that need to be taken care of by a different team?
All right, great. Well, we have 1 minute to the top of the hour, so we're going to close out Q&A now. But if we didn't get to your question, I'm sorry, but just folks know that the folks on today's webinar will be getting a copy of the questions, so I'm sure they'll be more than happy to follow up with you post-event. Before we close things out, I do want to do the drawing for the 3 Amazon gift cards. So our first gift card winner is Howard Belbin. Congratulations, Howard. Our next winner is Juan Chung. Congratulations, Juan. And our final winner is Roger Hegg. I think that's right. Congratulations, Roger. Congratulations to everybody who did win. And want to remind the audience that today's event has been recorded. So if you missed any or all of it, you can always listen to it again. We will be sending out the email post-event that contains a link to listen to the webinar on demand again. And it will also contain a link to that ebook that we referenced earlier in today's webinar. So Glenn, Vikram, Shiri, thank you so much for your time today. Great webinar, lots of information. I appreciate the time that you spent with me today. Thank you.
Thank you. My pleasure.
Great. We also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.